Hey everyone, this is part 3 of using the LJS Keyence software. What we've done so far is gotten our part in the measurement field of view and set up a position adjustment. So when I move it to the left and I click run, we track with the part. Next, and one of the most useful tools inside the LJS and X software is height measurement tools. So there's lots of different types of height measurement tools. The first tool is just height measurement. And what this will allow you to do is measure heights in a lot of different ways. So let's just say this is our part right here, and we need to measure the height of our part relative to the area around it. So to do something like that, I'm going to change my region to a circle. I'm going to drop a couple points along this dime, just like so. And perfect. So now what we've done thus far is you can see there's a bunch of different heights here. So there's max height H, max height X, Y, and Z. And if you notice, H and Z are the exact same. And that's because we have not set a zero plane. H is typically relative to a zero plane, where Z is relative to the sensor head itself, and or the center of the measurement range on the LJ. If I want to make this height relative to something else, I can click the zero plane specification right over here where my mouse is. So let's click on that, and let's look at a couple different zero plane options. So usually the easiest to implement zero plane is just 3 points real time. And what that allows you to do is, if you can see my little green cursor right here, we can drop a green point over here, and over here. And what that is going to do is it's going to make a zero plane with those 3 points. A great way to visualize that zero plane is by clicking this 3D button and then toggling your image into space just like this. So that way you can see, oh wow, my zero plane is right on my lower surface, and it's holding pretty tight. Another great way to see it, if I go back to 3D for a second, you can see some shading in the upper part of this image. Like right here. You can see that glossiness and that shading. And that's actually a really good sign. And why is that a good sign? That's because that is the zero plane being above and below that surface, which means that it's contouring or it's applying to the surface extremely well. So that's the pretty basics of a height tool. But the height tool can be used for lots of different things. Let's also say, you know what, now that I have this plane down here, I also want to detect the plane using this height tool. So now if I were to switch into 3D, you can see I'll have 2 planes. One is the zero plane, and the second is the detected plane. So if I toggle this into this direction, you can see my 2 planes right here. So if I zoom in, this bottom plane is my zero plane, and this top plane right here is actually created based on all of those thousands of height data inside this blue circle, and creates a best fit plane that way, which can be very useful for many different applications. Additionally, you also get an angular value out of it. So say you're trying to detect if a part is tilted. Well, you have all these different detected values right here that you can change. And then you have all these judgment conditions. And this is where you can put your tolerances in or your limits. We usually go by limits. What do these mean? Average height H is going to be the one that you use the absolute most. It's going to find the average height of this entire circle relative to your zero plane. So for this dime, it's 1.156 millimeters. But say you want to know if there's a random spike or the highest point. Well, you can see there's a minus mark in here and a plus mark in here. And what that is representing is the maximum height in that box. And then the minus is the lowest height in that box. So the maximum height we see is 1.36, and the lowest height we see is 0.128. But again, average height is what you're going to use 90% of the time, and you might use max height. That's a good demonstration of the height tool. Going off that height tool, say you wanted to have multiple height tools. Well, free multi-point height measurement and a range multi-point height measurements are the exact same thing as a height measurement tool, but you can have multiple different regions. So let's say I want a box right here, and let's add a couple more. 1, 2, 3. Now I have 3 different boxes. So I want to know the height here and the height here. What does this allow you to do? It allows you to inspect different regions for different height points. So say I had 4 different quarters on here. I could inspect the height of all 4 different quarters with one tool with just multiple regions. So that's a really good use case for this tool. Other than that, this tool can also be used for flatness measurements and detecting like curves on stuff. But yeah, that's a little bit going into the height measurement tool. And we can use this in many different ways.